Hello, this is Ms. DB, and today we are going to learn how to do Chapter 5, Section 6, which is on inequalities when you have two triangles. This is really going to be about the Hinge theorem and its converse. And we'll learn about that. Hinge theorem and its converse. All right, so it's called the Hinge theorem, so let's look at something that has a hinge. All right, so we've got this gate here. And it has hinges at A. Right here, there's hinges holding that gate on. That makes sense, like a door opening and shutting. And it swings open over here. I put point C on here so we can kind of see. So you can make this triangle be different sizes depending on how far you open the gate. If you open it really far, then you would have C would be right here, up here. And if you opened it just a little, if it's almost closed, then C would be shut all the way. Okay, so the length from A to B doesn't change. It's just going to change how long B to C is. All right, so the gate swings open. You can think of triangle ABC with side AC formed by the gate itself, and side AB represents the distance between the fence post, and side BC represents the opening between post B and the outer edge of the gate. So there's two things that don't change, right? It's like side angle side. We aren't going to change the gate, can't change the gate. We also can't change the opening between A and B without digging everything up, right? The only thing that's going to be changing is side AC. So in our first option, right here, the gate is almost shut and the length from B to C is pretty small. Also, the angle right here of angle A is pretty small. Okay, we're opening it a little farther now. Now the length from B to C is a little bigger, and the angle of A is also a little bigger. Now look at how wide we got the gate. Open as wide almost as we can. The length from B to C is quite big now, and our angle is also big. As the gate opens wider, both the measure of angle A and the distance, the length of CB, increase. That's basically what the Hinge theorem is. Let's look at it. The Hinge theorem says that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent. So the sides and the sides are congruent, but the angles are not congruent. So it's not side angle side because the angles are not the same. Then the longer third side is across from the longer, bigger angle. So whichever angle is bigger, the side opposite will be bigger as well. So if the measure of angle A is bigger, greater than the measure of angle D, then side BC will also be greater than side EF. The converse is also true. If, again, you have two congruent sides, then the larger included angle is across from the longer third side. So if we know that this side here, GH, is across from the angle, if we know that GH is greater than KL, this side over here, which would not be congruent, so I'm not going to put 3 marks, but if GH is greater than KL, then we also know that the measure of the angle opposite GH is greater than angle opposite side KL. So the measure of angle J is greater than the measure of angle M. So we'll use that in some triangles to be able to compare. We're going to be using less than, I didn't mean to push the button there. We'll be using less than, and we'll be using greater than. Do not mess up or mix up which one is which. They want us to compare the measure of angle BAC and the measure of angle DAC. So first we have to find that angle B, start here, go to A, then go to C. This is the angle we're talking about for BAC. And they want us to compare that to angle DAC. That's this one here. Now, so what we do is we look at the sides that are opposite those angles, the side lengths. So opposite the first one, BAC, is the side of 7. Opposite the other one with the side, with the angle, the purple one there, that one has a side of 6. So the greater angle is opposite the longer side length, which means that the measure of angle BAC, the blue one in the picture, is greater than the measure of angle DAC. That's what you're going to write for your answer right here. In a lot of the questions, all you'll have to fill in is the sign, either greater than, less than, or equal. All right, let's look at some side lengths. Side EF and side FG. They want us to compare these. So they want us to write less than, greater than, or equal. So EF and FG. We have to figure out what goes in that line. So EF is opposite the 82-degree angle. How am I going to figure out what is opposite? It's opposite what angle? Well, this makes a linear pair. 82 plus whatever the question mark is. So we first have to figure out 180 minus 82, that's 98. Now we can see that side FG is greater than side EF, or EF is less than GF. Make sure you're paying attention to which one's listed first. You could also write that GF was greater than EF, but if the segments are already there and you just have to fill in the blank, make sure you pick the right sign. Now the last one asks you to find a range of values. So that we've got some variables here, we got a little bit of algebra to do. Opposite angle PLN, this angle, opposite that is 18. Opposite the other one, 38, is 19. That's greater. 19 is greater than 18. That means that 5k minus 12 is less than 38. So we're going to write that down. 5k minus 12 is less than 38. Then we add 12 to both sides. They're doing this all in one step. Whoa. Such a touchy button on my pen. Add 12. And we get 5k is less than 50. Then they divided both sides by 5, and they got k is less than 10. So k here has to be less than 10. Now, it also has to be greater than something. So we know that it has to be less than 10. That's part of our answer. But we couldn't have this angle here being a negative number. It also can't be 0. It has to be greater than 0. So we're going to write that this, 5k minus 12, also has to be greater than 0. Then we add 12 to both sides. And we get 5k is greater than 12. And then we divide both sides by 5, and we get a decimal. K. Why did they write less than? It should be greater than. It's not a negative. 2.4, not 24. 12 divided by 5 is 2.4. So we know that k is greater than 2.4, and we also know that it's less than 10. And you can write that in words if you want, just like on the last one. You can say that k is greater than 2.4, and k also has to be less than 10, or you can combine it into one inequality like in their example. This is just another kind of simple example. Find the measure, or compare the measure of EGH, this angle, with the measure of EGF, this angle down here. So we look at the sides opposite. This one's 9, this one's 10. So then you know that the measure of angle EGH is less than the measure of angle EGF. This one asks you to compare side BC and side AB. So we're going to compare these sides. Well, one of them is opposite a 64-degree angle. One of them is opposite a 65-degree angle. So therefore, BC is opposite the bigger angle, so BC is greater than AB. Now, sometimes we will do problems like this. There is an interactive, you can kind of click through and try the different things out, optional. And then there's extra credit problems on your worksheet that have to do with problems like this. John and Luke leave school at the same time. So here's Luke, and here's John, and they're both heading the same direction. It says that John rides 3 blocks west. Here's John. So he would go west. I don't know why they drew the triangle that way. And then, wait, how can John go west and north to get to school? Oh, I'm sorry. They're leaving school. I'm totally wrong here. I read it wrong. So John goes west, and then he goes north. So here's where he ends up. He goes 3 blocks west and then 4 blocks north. Luke, right here, he starts here. He rides 4 blocks east and then 3 blocks at a bearing north, 10 degrees east. So it's 3 blocks, but it's not exactly 90 degrees. So this angle is 90 degrees because he went straight west and straight north. This is not exactly 90 degrees. It's 90 plus 10. And then the question is, who is farther from school? So we've got a 90-degree angle for John. We've got a 100-degree angle for Luke. And the question is, who went farther? So this one's the 90. This one's the 100. So opposite 100 is longer than opposite the 90. So that means that Luke is farther away from school at that time. You can also use the Hinge theorem in proofs. For example, we are given that AB is congruent to CD, and that the measure of angle ABD, this angle, is greater than the measure of angle CDB, this angle. This one's smaller. Prove that AB is greater than CB. AB is greater than CB. Where's CB? Oh, here's CB. So we start with our given, and then we'll use the reflexive property to say that BD is congruent to itself. Then, if you know that this is congruent to itself, we've got 2 sides that are congruent to each other. If we know that the measure of angle A, this is bigger, this is our greater than angle, and this is our less than angle. So this side must be greater than the other one. There's a mistake here. It's supposed to be AD. And that's all there is to this proof. We just proved that side AD is greater than side CB because the angle, its opposite, is greater than the angle that's opposite the other side, and that was part of our given. And there's the rest of the, that's the rest of the given. I forgot to make it come up first. There's another proof. I'm not going to go through all of it, but here is how you would do this proof, showing that measure of angle TSU is going to be greater than RSU. This time we'll be using the fact that the sides they gave us, one was greater than the other one. So when you use that, when you're trying to find an angle is bigger than another angle, you're actually using the converse of the Hinge theorem. All right, well, I hope that the main thing to focus on is the first part of this section on, let me show you again, these kind of problems where you are going to be comparing and finding a range of values. That's what almost all of your worksheet is on. So let me know if you have any questions. Thank you very much and have